We're not going to spend much time on the Gauss-Jordan method because it's just a variation of Gauss elimination. And the only difference between the Gauss-Jordan method and Gauss elimination, which is what we've done so far, is that when we eliminate an unknown from an equation, it's eliminated from all of the rest of the equations. So the normalization is done by the individual pivot elements. And effectively what we're left with then is that the coefficient matrix is reduced to the identity matrix, which means we don't need to back substitute to get our roots of the equation. So what I'm talking about is, for example, if we have a matrix set up with an n by n matrix augmented, so you can see the constants on the right side. What we would do is we would normalize each pivot coefficient. So the pivot coefficients are those on the diagonal. And what we would do is we would normalize them and remove from the other equations. So this setup would turn to normalizing A11 to 1 and removing it from all of the other equations. This is done similarly for the element A2, normalized and removed from all the other equations. And we carry on in this method until the nth pivot is eliminated. And you can see quite clearly that we are left with the identity matrix. So B1 has n operations done to it. Bn has n operations done to it. And effectively this can be rewritten as x1 down to xn being equal to bn with n operations, and this x1 is equal to b1 with n operations. Now this is an n by n matrix, which means that the amount of effort that we need to, well, the amount of operations that we need to do is initially n squared. So we perform our operations across the column, n columns and n rows. So this means initially we have n squared computations. But there's a further operation, there's a further cost increase through the normalization, which is of order, results in order n. So this becomes n cubed operations. So we can write this as complexity order n cubed. So this is very important because within each increase in n, there's going to be 3 orders of magnitude increase with 1 increase in dimension.